So in this problem, we want to find an exponential model for this data. Now, it mentions regression, but we don't need to do that to find the model in this case. So I'm going to find a model of the form f of t equals y naught times b to the t. Y naught is the initial y value, or what you get when t is 0, because b to the 0 is 1 when you plug in t for 0. So y naught is the value of the purchasing power. In this case, this is y right here. This is t. T is time. So y naught is 1 right there. Right, that's y naught right there. It's the initial value. Okay, it says if you do not have suitable technology, use the first and last data points to find a function. That's what we're going to do. So we're going to then use this data point. So far we know that f of t equals b to the t. And then if I plug in that point, let's see. T, we have to figure out what t is. Is t 2000? No, t is 0 right here. It says where t is 0 corresponds to the year 2000. So in this one, t is 12. So that means f of 12 equals 0.64. So plugging that in, we have 0.64 equals b to the 12. So we need to solve that. So we need to take the 12th root of both sides, which I'm opening my calculator right now to do. Okay, so we're going to take 0.64 to the 1/12. Okay, and that gets me 0.963, and I've got to jump over to the problem to see how many decimals. I'm going to write it out here first. 0.9635. Let's jump over to my math lab. Yep, right there, 0.963 to the t, so rounding to 3 decimals. That's what it says to do. Okay, and I think the rest of this you guys can get. So assume the model remains accurate. Predict the purchasing power in 2015. So you just plug in 15 and 18 and round to the nearest penny. And then on this one, you would need, if you probably would need a graphing calculator or something, or some way, or you could just guess and check until you figured it out when the purchasing power drops to 35 cents. So hope that helps on number 24.